Okay, we are beginning a new unit. Just so you know, the plan, regardless of any weather, is to do the Unit 6 CSA before spring break. Okay, so our plan is to take the CSA right before spring break, and then you have 0 math homework for spring break. I mean, that's okay, right? Yeah? Okay. Yeah. You're gonna have homework tonight, okay? Today is Wednesday. Okay. All right. So our unit 6 is all about 2 topics. Topic number 1, exponents. Topic number 2, scientific notation. Okay. So it's a lot of information, but not a lot of information because it's really 2 different topics. Okay. So today let's just talk about exponents. Okay. We know that repeated multiplication can be rewritten as an expression using an exponent. So 4 times 4 times 4 means what? 4 to the 3rd power, 4 cubed. Somebody said 64. Nice work. Okay. Now, everybody was right. 64, 4 cubed, 4 to the 3rd power. Okay. But I want to focus on the notation. Okay. 4 cubed means we're taking 4 times itself 3 times. Okay. Whatever this exponent is, that's how many times we're multiplying that number to itself. Okay. Now, whatever number this guy is, we call this the base. Okay. So up here, 4 was the base. And what do we call this guy? The exponent. Okay. So base is the number that we're multiplying over and over. What do you need, Cordell? I have one right here. Okay. Now, whatever we have, we're going to read it as, like this case, x to the n. This is x raised to the nth power. Now, when our exponent is 2 or 3, we have special names, right? Like squared and cubed. And that's fine to say, right? But otherwise, we just say whatever to that nth power. So 3 to the 6th power, or whatever it may be. Yeah, finish it. And then. Okay. So let's just talk about notation. This guy right here. How many times is 11 multiplied to itself? So it's 11 squared, which we know is 121. I know it feels like this is a little backwards. It's fine. Well, because we already know, like, we've already talked about this. Like, we're kind of taking a step. Okay. What about this right here? Corin, how many 2's are being multiplied together? So this we would write as 2 to the 7th. What is 2 times 2 times 2 times 2 times 2 times 2 times 2? Cordell, stop. Nice work, Brady. Hey, guess what? We get to use calculators in this chapter.
Yes.
For the rules. I know. Okay, now notice how in number 3 we have a negative. So when we have a negative that's being raised to a power, we need to put that base in parentheses. And then what is our exponent going to be? Okay. That's okay. All right. What is negative 5 times negative 5 times negative 5 times negative 5? Almost. Go, girl. Is it negative or is it positive? Okay. Quinlan, tell us why it should be a positive number. Okay, so a negative times a negative is a positive, right? So these two make a positive, and these two make a positive. Okay, now if it was negative 5 to the third power, that answer would be negative. All right. I want you to do that one for me.
How would you? No, Doug's trace 5 and 6. How would they?
All right, so I'm hearing some good discussions of those people who are doing what I asked them to do, of whether we need the parentheses with our base or not. When we have a fraction, I should just write 1/4 to the third power like that. We do need the parentheses if our base is negative or if our base is a fraction. Okay, now if we have 1/4 to the third power, what is that the same as? What is 1/4 to the third power the same as? What's 1 cubed? What's 4 cubed? So we're gonna write it as 1/64. All right, now in 5 and 6, we have some interesting things happening. Write down what you think we should write for number 5. Why plus? I don't know. Okay, so how many 7s are there? 2 being multiplied, and we're multiplying that to 3 4s being multiplied. So 7 squared times 4 cubed is how we would want to write that. I'm not going to worry about what that number is. We times it because look at this right here. This is all multiplication, right? So we need to keep it as multiplication. Okay, so knowing that, how about you write me what number 6 should be? Okay, so now, Corin, what do we have? Okay, if you agree with Corin, -2 cubed times 8 to the 4th. Okay, it is okay if you have those like as 8 to the 4th first. Okay. But make sure that -2 is in parentheses. If I asked you to multiply this out, I'm not going to worry about it right now. Would it be a positive or a negative number? It would be negative. Okay. It would be negative because -2 times -2 times -2 would be a negative number. Okay. All right. So now let's look at it when we have letters. This makes it easier, actually. Okay. Quinlan, how many A's are being multiplied together? A to the 9th. How many XYs in number 9? So we have XY to the 5th power. I know, it is weird. All right, write down what you think 10 should be. Check in with your elbow partner. Did you write the same thing for number 10?
What?
Okay, Tyler, what do you have for number 10? Okay, do you agree with Tyler?
Yeah. Yes.
Okay, so now when we do number 11, this is my expectation. Okay, in number 11, we see that there are how many K's? K to the 6th and 9 cubed. Okay, so I don't want you to leave it like this. I want us to actually make it look nice. We know that 9 cubed is 729.
Oh yeah, one of those ones.
So I want that coefficient to come first. So this would be 729 K to the 6th. Yes, it is. So then for number 12, we have 2 -7s, we have 3 M's, and we have 2 N's. Harper, what would -7 squared be?
Positive 49.
Ooh, positive 49. Nice work. All right, I'm gonna do something a little weird here. Everyone can drop their pencils. All right, so you're gonna do something for me. Okay. What is 2 to the 1st power?
First power?
Okay. 2 squared. 2 cubed.
8.
2 to the 4th. All right. I want you and your partner to discuss a pattern from 16 down to 2.
Oh, it's all like half.
Okay, so I'm hearing some really good discussions. Okay, what happens every time from 16 down to 8 to 4 to 2? Okay, I want 16 going down. What's happening, Quinlan? You said it. Yeah, so like from 16 to 8, we divide by 2, right? From 8 to 4, we divide by 2. From 4 to 2, we divide by 2. So if we continue this pattern, what's 2 divided by 2? It's 1. What's 1 divided by 2? How about 1/2? Right? 1/2 divided by 2 is 1/4. Okay, so do you think that's kind of weird?
Yeah, sure.
Okay, so number 1, Jada, anything to the 0 power is what? Is 1, okay? This is going to be something we're going to write down here pretty soon. But what do you notice? 2 to the negative 1 is 1 over 2. 2 to the negative second is 1 over 4. I'll even do this for you. 2 to the negative third is 1 over 8.
Oh, so it's on the bottom, it's the same at the top.
So what's 2 to the negative fourth?
1 over 16.
Oh! Why'd I do what? I'm excited. Like, this is so great. So turn the page. No, now you have to write this down. Page 3. Any number raised to the 0 power is 1. 1 to the 0 is 1. 2 to the 0 is 1. 3 to the 0, 4 to the 0. Anything to the 0 is 1. Yeah, you've been doing a great job. Okay. So then what you told me, remember you told me this. If we have a negative exponent, then where did the number go? It went on the bottom. Okay. So x to the negative n can be rewritten as 1 over x to the n. Negative exponents just really aren't okay. So we are going to move it across the fraction bar to make it better. Okay. So it's going to go downstairs. It's really cool. So like in number 15, 5 to the negative 2, we would rewrite as 1 over 5 to the 2. Once it moves across that fraction bar, it becomes positive. So we would write it, yes, as 1 over 25. Eight to the negative 2. We could rewrite as 1 over 8 to the 2. It kind of is pretty great, isn't it? So we would write this as 1 over 64. So how about you rewrite for me 17, 18, and 19? Didn't you close the bathroom?
You said no because you said I could.
Yeah, and then you asked me, I said, yeah, you can go. Okay, Trent, what is number 17 the same as? 9. Jada, what's number 18 the same as? Okay, 1 over 256. So Jada rewrote 1 over 4 to the 4th. And 4 to the 4th, she figured out was 256. So what I would do in this case, I would figure out what 4 to the 4th is instead of trying to do like fraction times fraction times fraction. Okay. All right. Number 19, Ryan, what is this the same as?
What? Oh, 1 over 10.
Okay. And what's 10 cubed? You should.
300?
1,000. Okay. All right. So let's jump down to like number 23. 23 is interesting. Okay. Is this a negative exponent? No. So we don't have to rewrite it. However, 9 to the negative second would have to be rewritten as 1 over 9 squared. Okay. Well, what is 3 to the 4th? Somebody with a calculator, 3 times 3 times 3 times 3. 81.
It's
Oh, I was going
4.
for,
Times 1 over, what's 9 squared? 81. What? Okay, remember, if we need to put over 1, okay, to multiply two fractions together, we would have 81 over 81, which is 1. Okay, so now look at number 25. Okay, I actually think it's easier when they're not numbers for our bases, because x to the negative 9 is just 1 over x to the 9th. A to the negative 4th is just, everybody, okay, that's not really quite the response I was hoping for. 1 over a to the 4th. I know there's just some. All right, now 27. What a great problem. Okay. R to the negative 6th. Let's rewrite it. Okay. Times s to the 0. What's anything to the 0?
0.
That's why I yelled it. And then t to the 11th. Okay. Remember, these have pretend 1s as their denominator. So we have 1 times t to the 11th over r to the 6th times 1 times 1. Last problem, then I'll get you your homework. Okay. 3 to the negative 3rd. 1 over 3 cubed. M to the negative 4th. 1 over m to the 4th. N to the 5th. Do I rewrite it? No. Okay, it has that implied over 1. So what we have is n to the 5th over 27 m to the 4th. And I would expect you to write 3 cubed as 27. But the good news is you do get a calculator in this chapter. So this is what I want you to do for homework. I want you to do page 4. Go ahead and cross off number 10. But I think you can do the rest.
Oh,
You have 5 minutes that we're gonna stay in our own seats, but you can get, I bet, a good portion of this done, especially that top half.